Welcome to Ask and Learn.
This is the answer to Chapter 15, problem number 8 from the Smith Organic Chemistry textbook. And this problem is asking us to calculate the energy from the rate determining step of the free radical iodinization of methane to make methyl iodide and hydroiodic acid. And so remember that for these reactions, the rate determining step is going to be the formation of, and pardon me, I forgot the radical there. There it is, the formation of this this methyl radical. So the CH3 radical right here, the formation of that is the rate determining step. So that is formed by this reaction that I've drawn here. And so recall that when a CH bond breaks, that takes 435 kilojoules per mole. So a good amount of energy. And then on the other side of the arrow, this HI bond is forming. And the formation of the HI bond only releases 297 kilojoules per mole. And so that's less exothermic than an HCl bond or an HBr bond forming. And so the overall delta H naught is 435 minus 297, or positive 138 kilojoules per mole. And so that's quite endothermic. It's more endothermic than, again, a comparable reaction with chlorine or bromine would be. And because it's so endothermic, it could also be said to have a high activation energy, which, remember, is what EA means. And so since it has a high activation energy, in the absence of adding a lot of heat to this reaction, the reaction is going to naturally occur very slowly. Because remember, the more endothermic it is, the more energy that it needs, the harder that it is to just naturally overcome that energy barrier by the random collisions of molecules. And so the more positive that this number is for the delta H naught, the slower the reaction is going to occur. And 138 kilojoules per mole is fairly positive. It's a fairly large number. It means it's fairly endothermic. It has a fairly high activation energy. And again, that's why this reaction occurs so slowly. And that is the answer to Chapter 15, problem number 8.